Hey kids, welcome to section 8.5, chi-square test for variance or standard deviation. Today we're going to learn how to do a hypothesis test for variances or standard deviations using the chi-square test. So you will need your chi-square table that looks like this when doing your critical values. So, after the degrees of freedom reach 30, notice that the table only gives values for multiples of tens. When the exact degrees of freedom sought are not specified in the table, the closest, I don't know why that says smaller, it should say larger, because it would be better to overcompensate than to undercompensate. So, for instance, when we get down here to the bottom of the table, if my degrees of freedom were, say, 36, I would round up to 40 instead of down to 30. We have three assumptions for this chi-square test. We have that the sample must be randomly selected from the population, that the population must be normally distributed no matter the population size or sample size, and that the observations must be independent of each other. We have a formula for the chi-square test for the critical test statistic. We're going to do chi-square equals n minus 1, that's sample size minus 1, times s squared, that's your sample standard deviation, divided by chi-square or sigma squared, which is your population standard deviation. Notice we have degree freedom equal to n minus 1. Then I've got your 5 steps for the hypothesis test listed. State the hypotheses and identify the claim. Find the critical value and draw your picture, compute the test statistic, make your decision, and then summarize your results. So the same 5 hypothesis test steps. All right, so math SAT test. The standard deviation for the math SAT test is 100. The variance is 10,000. An instructor wishes to see if the variance of the 23 randomly selected students in her school is less than 10,000. The variance for the 23 test scores is 7,225. Is there enough evidence to support the claim that the variance of the students in her school is less than 10,000 at alpha equals 0.05? Assume that the scores are normally distributed. Okay, so for this type of hypothesis test, we need an N, we need a degree of freedom, we need an S, and we need a sigma. Now, sometimes your standard deviations are given as variances, and so therefore our variables over here are going to be squared. So let's take a look. First of all, we have 23 randomly selected students, so that's your sample size N. Take away 1 gives us degree freedom of 22. It tells us that the variance for the test scores, that's your S squared, is 7,225. It tells us that the standard deviation for everything is 100. And then it goes on to say that the population variance is 10,000. All right, so then we go to our hypotheses. Since our claim is that the variance is less than 10,000, we're going to be doing our hypotheses test with variance. So our null is that the population variance sigma squared is equal to 10,000. Therefore, our alternative hypothesis is less than 10,000, and that is our claim. So then we draw our picture. We are shading left. So we're going to grab the entire alpha, which is 0.05. Now, when we do our critical value, our chi-square, we want to make sure that we choose the one on the left-hand side of the table since we are graphing on the left. So we want degree freedom 22 and 0.05. Let's make this a little smaller so we can see it. So our degree of freedom is 22. We have 0.05 as our alpha. So we have right here, except we want the left-hand one. So we want 0.95. So our critical value is 12.338. Now it's never going to be negative, that critical value. So we just leave it as 12.338. So chi-square critical values are always going to be positive. All right, let's calculate that test statistic. So we have n minus 1 times s squared over sigma squared. So that's going to give us 23 minus 1. Our sigma squared is 7,225. I don't have to square it, or it already is squared. And our sigma squared is 10,000. Again, that's already squared, so I don't have to square it. Now my chi-square critical value had 3 decimals, so my chi-square test statistic is also going to have 3 decimals. If I type this in, I get 15.895. So now we compare. The cutoff for the critical region is less than 12.338. We are at 15.895, so we are not in the critical region, so we do not reject the null hypothesis. So since 15.895 is not in the critical region, we do not reject the null hypothesis. All right, so we are not rejecting the null hypothesis, and our claim is the alternative, so there is enough evidence to support the claim. There is enough evidence to support the claim that, and our claim was that the variance is less than 10,000. That the variance is less than 10,000. So the question, is there enough evidence to support the claim that the variance is less than 10,000? And the answer is yes. Oh, wait a second. My bad. Okay, we need to change this real quick, because the sentence is actually, there is not enough evidence. My bad. There is not enough evidence, so the answer is no. Okay, next example has to do with outpatient surgery. A hospital administrator believes that the standard deviation of the number of people using outpatient surgery per day is greater than 8. A random sample of 15 days is selected. The data are shown at alpha equals 0.10. Is there enough evidence to support the administrator's claim? Assume the variable is normally distributed. All right, so we need an N, an S, a sigma, and a degree of freedom. So they tell us that our sample size is 15. That's our N, which makes our degrees of freedom 14. It also tells us that the standard deviation of everything is 8. So that's my sigma. I do not have my sample standard deviation. However, I can use my calculator to find my sample standard deviation by entering the numbers in and doing a 1 var stat. If I do that, I get a sample standard deviation of 11.2. I rounded it to 1 decimal because my data had no decimals. All right, now I do my hypotheses. My null hypothesis is that sigma equals 8. And my alternative hypothesis is that sigma is greater than 8, and that is my claim. So I'm going to draw my graph. I'm going to shade to the right because we're greater than. I'm going to grab my entire alpha, which is 0.10, and then I'm going to find my critical value. I shaded right, so I'm going to pick the critical value on the right. So let's go to my table. Degree of freedom is 14. I'm at 0.10. So let's get rid of this other stuff. I'm at 0.10, so that is right here. So I'm going to find my critical value of 21.064. 21.064. All right, let's find our test statistic. Chi-square equals n minus 1 s squared over sigma squared. So that's going to be 15 minus 1 times 11.2 squared over 8 squared. If I type this into my calculator and round to 3 decimals, because that's what chi-square values are, I get 27.440. So my cutoff for the critical region is 21.064. I'm at 27, so I'm in the critical region, so I reject the null. So since 27.440 is in the critical region, we reject the null. So since we reject the null and our claim is the alternative, there is enough evidence to support the claim. There is enough evidence to support the claim that, and the claim was that the standard deviation is greater than 8. That the standard deviation is greater than 8. So there is a question, is there enough evidence to support the claim? And the answer is yes. All right, kids, we got one more. Nicotine content of cigarettes. A cigarette manufacturer wishes to test the claim that the variance of the nicotine content of its cigarettes is 0.644. Nicotine content is measured in milligrams and assume that it is normally distributed. A random sample of 20 cigarettes has a standard deviation of 1.00 milligram at alpha equals 0.05. Is there enough evidence to reject the manufacturer's claim? So we need an N, a degree of freedom, a standard deviation, and a population standard deviation. Looks like our sample size is 20, which makes our degrees of freedom 19. It tells us that the standard deviation of the sample is 1.00. And then it tells us that the variance of the population is 0.644. So I'm going to put a square here and 0.06 or 0.644. So then we do our hypotheses, the null and alternative. My null hypothesis is that the variance sigma squared is equal to 0.644. And that is my claim. To reject it, I'm going to say that the variance is not equal to 0.644. When we draw our picture, we are shading two sides because it's not equal to. So we're going to take our alpha divided by 2. So each section is 0.025. When we find our chi-square critical values, we will have 2 of them. It's no longer plus or minus because it is not the same number. We will have 2 different numbers. So we need degree of freedom of 19 with 0.025. So degree of freedom is, what did I say? 19 and 0.025. So we are in this column here and then symmetrically on that column. So we've got 8.907 and 32.852 are our two critical values. So the first one was 8.907. The second one was 32.852. All right, so when we do our test statistic, chi-squared equals n minus 1 s squared over sigma squared, we have 20 minus 1. Our s is 1.00 squared. And we already have our sigma squared, 0.644, so I don't have to square that. If I type this into my calculator and round to 3 decimals, like my critical value, I get 29.503. So we compare. Our cutoff is 32.852. We are not in the critical region, so we do not reject the null hypothesis. So since 29.503 is not in the critical region, we do not reject the null. Okay, so we are not rejecting the null hypothesis, and the null is our claim. So there is not enough evidence to reject the claim. There is not enough evidence to reject the claim that, and the claim was that the variance equaled 0.664, that the variance is 0.644. All right, so the question, is there enough evidence to reject the manufacturer's claim? And the answer is no. All right, kids, that's the end of section 8.5. If you guys have any questions, please let me know. And as always, keep calm and keep trucking.